I have the honor of a sort of announcing, a soft announcement of a tech preview offering at Red Hat, and it's a trusted artifact signer. It is a private Sigstore. So this talk will be kind of going through Sigstore in general and the TAS. I might just refer to it as TAS also. So my daughter drew this because I was a bit stressed out with all of these things in my head. This is the third talk of the day, and then I'm good now. Yeah, so these are all components that we'll talk about throughout the presentation. And basically, we all know, and you've probably heard it like 10 times today in different talks, that software supply chains are not ideal. It's top of mind for most enterprise software companies, and most enterprise software companies do it okay. There's always, those attacks that are in the news. But then if you take the Wild West of open source, and that, always makes its way into code bases, and that's, before we know it, there's SolarWinds and Log4j in the news. So yeah, it's especially with the distributed nature of applications today and the different hardware, it's just nearly impossible to lock down your infrastructure. And so it's even more important today to make sure that you have security through and through your code base, from your commit through your build pipeline to the production, because you can no longer just depend on your own boundaries. And so also key management is really not ideal. That's why not too many individual contributors really bother to sign, and if they do bother to sign, they're definitely rarely verifying those signatures. Software signing, though, can help with keeping pipelines somewhat secure. Digital signatures freeze objects in a state that can be, verified to be, something can be verified that it is what it says it is and that it hasn't been altered. That's the idea with digital signing. And but keys and key management, that can be prohibitive. So adoption of digital signing, it has been kind of slow, and the go-to right now is GPG or PGP, and yeah, very rarely does it get verified. So even no matter how well you sign your stuff, if nobody's verifying it, it doesn't do anything. And so that's where Sigstore came in. It aims to make signing and key management simple, and transparency reigns supreme. In fact, Sigstore introduces a concept of keyless signing. I think that it has been around in other projects, but Sigstore definitely took on with. And it's a framework and a set of tools for signing software artifacts like software bill of materials, binaries, RPMs, container images. This project is the foundation of Trusted Artifact Signer. It's sort of like what OpenShift is to Kubernetes, Trusted Artifact Signer is to Sigstore. We add a bit of OpenShift opinions and sane defaults, and yeah. And also, if you think about it, Sigstore is to software signing and provenance as Let's Encrypt is to HTTPS. There are many communities, protocols that have frameworks that have been popular lately, like for SBOMs, there's SPDX, Cyclone DX. The update framework is used in Sigstore for maintaining a root of trust and managing that root of trust. There's an in toto specification for meta-driven attestations. And SALSA, we've all heard of SALSA, the granular description of different levels of security. For now, it's describing the build pipeline. Is your build hermetic? Does it, yeah. And, but Sigstore is becoming this new standard for signing and verifying. And Red Hat is incorporating Sigstore into its own internal build pipelines, as well as incorporating Sigstore into many of its offerings. So Sigstore makes signing and verification easy. It takes the key management out of the equation. And also, sometimes what makes a tool or a product become a standard is just the adoption of it. And Sigstore has taken off, and there's a big community of developers. And in fact, there is a public good instance of Sigstore that is maintained by a group of SREs from different companies. And that, including me, Lily Sturman from Red Hat and myself, we meet weekly with some people from Google and ChainGuard, and we take turns getting pager duty and on-call shifts, and we keep it running. We keep it updated. I'm just learning the ropes right now, but yeah, we're very serious about keeping this running so that open source projects, individual contributors utilize it and just make signing software the norm, like HTTPS is now. And so we'll go through this a little bit individually. There's a picture, so don't worry after. Well, you might not be able to see it. You're all so far away. But here are the components of the Trusted Artifact Signer. Most of these are part of the Sigstore project. It's a BYO OIDC provider. So you bring your own, well, we do include a Keycloak and Red Hat SSO. We suggest that, and there's documentation, and you can easily get up and running with exactly what you need with an OIDC provider with Trusted Artifact Signer, but you really can bring your own provider. You can hook into Google or anything else. Actually, in the demo, I'll show you some. I have Sigstore running on a Rosa cluster, and that's super convenient to run TAS on Rosa because you can utilize the AWS identity provider, and then you can set up workload identity tokens in your pods. And so you don't have, it takes, with workload identity tokens or service account tokens, it takes away the interactive flow if you've ever used Sigstore where a browser pops up and you have to put your password in. Yeah. So BYO OIDC, also you bring your own your root certificate and keys. We also, we do show you how, the SSL commands to do it, but most companies or organizations are going to bring their own. It's interesting how the public good instance did it. It was a public key signing ceremony where there are different members of the community, 5 key holders, all live streamed the signing of the public good instance keys, and that's how they did it. But TAS does include the tough server for your trust root and sets that up. So the tough server serves your public key and your root certificate so that the clients can use it to verify. So you don't need to have that public key in your dot folder, and like I never know where any of that is. And then that's the first part of the stack. And then Fulcio is the CA server. It issues short-lived code signing certificates, and they're based on an OIDC identity. The certificate transparency log is the append-only verifiable transparency log for the signing certificates. That's the first transparency log in the chain. And Recor then is a server and for validating this signature and metadata. And that includes a second transparency log. And that second transparency log is Trillion. Trillion's the back end for Recor. And again, it's tamper-proof, append-only, immutable. And then the clients. So the way Trusted Artifact Signer works is it runs on OpenShift. And these clients are, you can grab them from the console. So a lot of our partners and customers enjoy having Red Hat built tools and packages. So these three popular clients are in our internal build pipeline now, and they're offered through the console downloads. If you've ever downloaded OC from the OpenShift console, yeah. All right. And so here's the monster diagram. Now there are like so many blogs, diagrams, posts, videos that describe. We're finally going to talk about keyless signing. I'm not going to pretend to be the expert, but that's the whole point. What used to be just for the most security-minded people in a company is now really important for every developer to be utilizing signing with every Git commit, with verifying, and every project should be checking that the commits are signed, and that's the only way we're going to. Okay, so in a nutshell, cosign issues ephemeral. This is keyless signing. Cosign issues ephemeral keys. It's not actually keyless. And with the private key, Fulcio issues a short-lived signing certificate. An entry is logged in the certificate transparency log that proves that certificate was signed within the 10-minute period. That's the default, that the certificate was valid. And once that log is there in the first transparency log, the keys can be discarded, because that entry gives a long-term proof that signing was good. And that is bound to an identity. And then it's returned to the client, goes to Recor. Recor then takes the signature and the public key and adds that to a second transparency log, the Recor log. And that's what you can use the Recor CLI to query later. And so that's pretty much it for keyless signing. And the signatures are, like I said, they're stored in the log. The artifact themselves are stored in the, they're entered in the log, but then they can be pushed to a container registry alongside the artifact. And it's an OCI object. It can be stored in a container registry, which is super convenient. And another picture, which you can feel free to look at my slides later, but it's just describing that flow that I talked about where Fulcio and the client generate the certificate. Same with Recor. They sign and publish the artifacts to the registry, and then the signature is published to the log. And then the clients. So let's see it in action. These are all the pieces. We have a script. It's actually a bash script, which will probably become a bona fide installer at some point, but it's fail-proof. You can, it takes just a few minutes. It connects to your cluster. It sets up that whole stack that I just described. and you're up and running. There's a list of environment variables to connect and initialize cosign with the stack, because by default cosign connects to the public good instance. So there's that, and this isn't the way that we think, this isn't the way you should sign things, but you can take cosign on your local system and sign your artifact, push it to the registry, and verify it later. That's just for like testing and trying it out. But what you'll really want to do is integrate signing into your CI/CD system. It should be part of your build process. Yeah, in the demo I show the Amazon Software Token Service, STS, with the identity provider, and it does everything with workload identity in the pod. And then you can verify that your artifact was signed with a particular cluster, a particular service account. It takes the whole, do I trust a human out of the equation? And sometimes that's good. So the way I see it in the futures, workload identity, Spiffy Spire, and I should mention that what's next and what we'll be working on is Sigstore integrations. Like Tecton Chains is this amazing pipeline, OpenShift pipelines. It's the same. You just configure it with your Sigstore stack, and it builds your image. It pushes with Builda, pushes it to a registry. There's also emission controllers that can enforce the image signatures on a pod so that it won't run. I should have mentioned Podman. Podman also has ability to gate on Sigstore signatures. And then there are lots of policy enforcement tools. And I should mention Red Hat Advanced Cluster Security and actually that, yeah. Well, anyways, lots of Red Hat initiatives for Sigstore in the pipeline, no pun intended. So keep your eyes and ears open. And if you do grab my slides, you can watch that demo. One more thing, we also have in the stack a monitoring solution. So there's a dashboard that shows in Grafana how many certificates have been issued, and yeah, so that's another piece that we add to the Sigstore stack. So, yay, TAS, Trusted Artifact Signer.